Hello, everyone. This is Jason. We're going to talk about domain and range for just a few minutes. Finding domain and range from a function is kind of a simple thing because we're just kind of looking for some limiting factors that's going to help us out. So we're going to take a look at a few functions here. We're going to look at f of x equals x squared. We're going to look at f of x equals 3 divided by x. And we're going to look at something like f of x equals the square root of 2x plus 5. So now how can I find domain and range for these things? One of the easiest things you can do is to look for limiting factors in the function. So what are some limiting factors in the function? Things that's going to limit what your domain can be. Remember, domain are the x values, any x value that you can put into the function. The range are going to be all those y values that come out. So what are some limiting factors? So one of the biggest limiting factors is a denominator, and I'm going to abbreviate that with a variable. That will limit your domain because denominators cannot equal 0. So we have some limiting factors there. Some other things that will limit it: square roots and fourth roots. So you see we got a couple of examples there, and I picked those on purpose. So even roots will have some limiting factors that you can put in because on those situations we have to have positive values come out of the function. And then some other things, and we'll talk about those probably in some later lessons, are things like the logarithm function, the natural logarithm function, and exponential functions. And those special functions like that will limit your domain. So what are some things you can do to visually kind of see what we're talking about? Well, one great tool that you can use to help you with domain and range is Desmos Graphing Calculator, desmos.com. So anytime I'm looking at this and I want to figure out domain and range and I'm not sure in my head 100% what I'm looking for, I'm just going to enter these things into Desmos. So here's Desmos. My first function there was f of x equals x squared. So I'm just going to do y equals x squared. And you see there's the picture. And what I can see right away is that this thing is going to extend forever in each direction on the x value. So there's not going to be an x value that I can't put in. So back over here, when I do my domain, so I'm going to pull this, give me some space here. We're going to look at each one of these individually. So if we look at f of x equals x squared, because there's nothing that's going to limit an x value from going in, none of those special things, the domain will be all real numbers. And that's real, Jason, right? Real. So there's real. So we can write this as negative infinity to infinity. And there's some other ways to write it, but that's kind of how we're going to write it for our purposes. And now let's look at the range. So what's the range? The range is going to be limited here because this is a quadratic function. So there's lots of other things that exist that helps limit the range. So that's why looking at that graph is a lot more useful here. So if I look at my graph, you see it stops right here. It doesn't go anywhere down in the negatives. So it stops at 0 right there where that vertex is. So I know that my range has to be values above 0. So we're going to write that out back over here. We know that our range is going to be from 0 to infinity. Or here we can actually say, not x, that's going to be the y's. Y has to be greater than or equal to 0. So that's a couple of ways that we can write the range. So look, the domain, we're going to kind of look at the function. Range, we're going to look at the graph. That's going to kind of give us the ideas. And we're going to use Desmos to help us with this. So let's take a look at the next one. The next one was 3 over x. So again, 3 over x. We're going to talk about this domain-wise first. So we're going to look at the graph first. I like looking at the graph first. So we're going to change that from x squared to 3 divided by x. And you notice that there's kind of a discontinuity here, some kind of a jump in the graph here, right here on this line. You see it never crosses that line in either direction. So that's going to be a limit to our domain because it looks like I can't put in 0 to the function. Now, how do I determine that from the graph or from the function itself? Anytime you have a denominator that has a variable in it, so variables in the denominator, we're going to set that equal to 0. So even if I added a variable, a number there, and we'll do that here, set those equal to 0. That's going to give me the limit to what my x's cannot be. So here x cannot equal 0. If I added that 2, so the original function, let's put it up here so we know that we are talking about two different things here. So for this one, the limit is x cannot equal 0. On this amended graph here, if I subtract 2, I know that x cannot equal -2. So that's how you're going to get your limits to your domain. Now, how would I write these domains out? For this first situation, I'm going from -infinity to 0, and then we're going to have a union that goes from 0 to infinity. Sometimes it's acceptable to say it's all real except x cannot equal 0. And the same thing would be true over here. I would go from negative infinity to -2, and then I want a union there and go -2 to infinity. So I hope that helps you with that. Now, what about the range? Let's go back and look at the graph to check the range out. Well, it looks like the range is also limited. Looks like 0 can't be part of the range either here. So we have this, right here, it never crosses. So we're going to have a similar situation for the range. So the range here, same sort of situation. We can't have 0. So we go from -infinity to 0. And then we're going to union that 0 to infinity. So we're going to let Desmos help us with the domain and range so we can see if there's any limitations. And just kind of use the function after we know there is a limitation to see where it is. So let's look at this last example. Trying to not extend this video more than I need to. And we've got y equals the square root of 2x plus 5. So limiting situation here is that to take square roots, we have to have positive values. So we can't have a negative outcome in that radical. So we're going to take this and say that it has to be greater than or equal to 0. And so we'll just solve that out real quick. We'll subtract 5. And that'll give me 2x is greater than or equal to -5. We'll divide by 2. And so x has to be greater than or equal to -5/2. Now, I'm pretty sure when we go look at the graph, that's going to be my range, that my range is -5/2 to infinity. And that's going to be included in it. So we'll put a bracket on the included value. So let's go and look at the graph. So we're going to change that to square root. And just to save time, I'm going to use this. We're going to have 2x plus 5. And I'm going to get rid of this. I don't know why that carried over. And 0.5 is the same as square root. So I'm going to do it like that. And you see right there, that's at -2.5, just like we found. Now, if you also look, there's no values down here. So now I know what the range is. The range can't be negative. The range has to go from 0 to infinity. So that's going to be my range So we're going to write that down. So our range is going to be from 0, and that's included, to infinity. So I hope this helps you with domain and range. If you still struggle with this as you're working, please let me know and I will get you some additional resources.